Okay, everybody, now that we know what's going on with the mole and we can define it, we defined it in terms of volume, we defined it in terms of mass, and we also defined it in terms of number of particles. We now can see what this thing can do. Again, the mole is not just a thing we kind of like hang out with and just look at it or just know that it's there. What we can do in this case is use it to solve a whole bunch of problems in science and in chemistry. So it really does help with a lot of things along the way. So let's look at the first thing we're going to look at, and that's something called percent composition. And in percent composition, you've probably seen this before in math, where you're looking at the piece of a whole or part over a whole. Okay, and what we're interested sometimes is we're interested in the amount of a particular element within a compound. All right. So maybe the element you're interested in is oxygen. Maybe that element is interested, maybe you're interested in gold. Maybe you're interested in magnesium, and it's in a compound, but you're interested in getting that amount, or how much you're interested in the amount of that particular material within another sample. All right. So this can be very helpful. All right. So we're interested in the amount of a particular element within a compound. So you're looking at the part that's inside the whole. That's really what we're going to be looking at. That's really important. So just as I guess an example, just let's say in the future, travelers to Mars will definitely need oxygen. We know that Mars doesn't have much of an atmosphere, right? So in order for us to live on Mars, we would have to create an atmosphere that has oxygen in it. But the oxygen on Mars is pretty much all bound up in rocks, okay, in rust. Okay, so basically the surface of Mars is coated with layers and layers of iron oxide, and there is oxygen in the iron oxide. Now, of course, you can't breathe the iron oxide. You need to breathe oxygen. So we have to find a way to get a certain amount of this iron oxide and take the oxygen out of the compound. And we would need to get enough of it so that we could create atmosphere. So I would want to know, like, well, how much oxygen can I get out of a certain amount of iron oxide? Or what's the percentage of oxygen in a certain amount of iron oxide? So let's just say I had 100 grams of iron oxide. Well, how much oxygen is really in there to use? Okay. So that's important too. Now, again, in a standpoint of this, you can also use the iron, right? So what's the percentage of iron in here? If you wanted to think of that way too, because then if you needed to, you could take the iron and build things with it. So I mean, it's a little far fetched, but at least it's an idea. There's a picture of Mars for you. Okay, so when we look at percent composition, we're simply looking at the part over the whole, and this can be done for any type of percent composition. However, in chemistry, we're looking at the element part that you're interested in over the entire compound. Okay, times 100. Okay, and that will give you percent composition. Now, of course, we know that compounds are always set by nature, right? We know that this is a definite composition, right? Because that's what the definition of compound is. So if that's a definite composition, then the composition of iron oxide is the same all the time, regardless of how much you have. You can have a little bit of iron oxide, or you can have a whole big pile of iron oxide, okay? And the percentage would be the same. Okay, so percent composition is always constant for any compound and is set by the mass ratio of elements in the compound. So it doesn't really matter how much of you have, you always have the same percentages. So it really doesn't matter what we use, it doesn't really how much we use, we can figure it out. And that's why the mole is going to be helpful. Okay, so we can actually use the GFM for this. We do have a mass to use, and that's the GFM. So we can use the GFM to find the whole. So if we take a look at iron oxide, okay, we're going to see that there's two irons in there. The GFM of iron is 56 grams per mole from the table, and that's going to be 112, okay, grams, okay, per mole, of course. Okay, and again, we can make sure we use that in there. Okay, oxygen is 3 of them, and that's times 16 grams per mole, all right, and that would be equal to 48 grams per mole, okay? And together, the total, if you add everybody together, you would get a grand total of 160 grams per mole. Okay? So there is your whole, right? That's your whole, that's your denominator of this. Okay? And the next, we're going to do the part over a whole. Now, here's the tricky part. Make sure when you do this, you use the entire part. Okay? Use all of the oxygen, not just the 16, right? You just don't want to use just straight O, because there's, in Fe2O3, you have all three O's. So you need to make USOR, that's the part. All right. So basically, we're going to be looking at the part on this. Let's do this again. Sorry about that, guys. 160 grams per mole would be my whole. Okay, so now I'm going to use the entire part. So I'm going to take O3 basically over Fe2O3, which is going to be now 48 grams per mole, okay, divided by 160 grams per mole. Okay, and if I do this right times 100, should get around 30%. Let's just confirm that really quickly with my calculator. Okay, if I take 48 divided by 160, please play along with this so you know that's exactly 30%. Okay, so we could say that really 30% what? 30% oxygen. And since there's only two elements in there, I can always also say that I have 100% minus 30% oxygen is equal to 70% iron, right? So that simply means that percent composition means that any amount of iron oxide is always going to be 30% iron, okay? And it's always going to be 70%, 30% oxygen and always 70% iron. Okay, so 30 oxygen, 70 iron for a total of 100. And that doesn't matter whether you have 100 grams, 20 grams, 2 grains, a truckload. It doesn't really matter. So we can always figure out how much we're going to do with this. Okay. Another type of thing is using this percent composition in a certain problem. So I'm going to try this problem. Okay, we see how we could do this. So let's just say you're camping somewhere or you're out somewhere and you come across an old gold mine and you find a can of KAuCN2. Okay, so KAuCN parentheses 2 is interesting because think about it. You have gold in here. So how much gold can you get out of 500 grams of potassium gold cyanide, which is this is potassium gold cyanide? So again, I'm not looking for the potassium. I don't care about the potassium. I don't care about the carbon. I don't care about the nitrogen. I'm interested in gold. Gold's expensive, right? So I really need, number one, you want to find the percent of gold in this, right? Let's find the percentage of gold in this, okay? And then take that percentage and figure out how much of 500 that would be. All right, so find that out. All right, so we're going to need the part, right, over the whole times 100. Okay, so we're going to have to find the part and the whole. So let's figure out what the GFM is of the whole thing. So we're going to say K, there's one of them, AU, there's one of them, CN, watch formulas here, there's two of them, and N, there's two of them. So 1, 2, 2. Okay, potassium is 39. I'm not going to put the units here. Gold is 197. Carbon we know is 12. Be careful, make sure you use the masses in here. Don't want to use atomic numbers, we're using masses. Okay, if I multiply all this out, I get 39, I get 197, having fun. 24, I'm sorry, and 28. Okay, so if we add all of these numbers together, we'll get a grand total of 288 grams per mole. Okay, just take a quick note. Notice how much heavier gold is than the rest of these elements. So gold makes up most of the mass of the whole thing. Okay, so now I will do my part over whole. So I will take my gold that I'm interested in because I'm asking for how much gold in the problem. Okay, over my whole thing, 288. Again, this is grams per mole. This is grams per mole. I'm going to take that times 100, and I'm going to get 68.4%. I'm just going to leave it as a decimal, gold. Okay, so that would be the percent composition of gold. Again, I'm not asking for the other elements. I mean, they can ask for other elements, but I'm more interested in what the gold is because gold is expensive. Okay? So now the question becomes, well, what can I really do with this? I have 500 grams of this. So the second part of the problem is now I have 500 grams, you have 500 grams, and we know of the whole thing, right? I have 500 grams of this material that is 68.4% gold. So how do I go about figuring out the amount of grams of potassium of gold that's in there? Well, I could do it two ways, right? I could say, well, I could take 500 grams, okay, and multiply it by 0.684. This is probably the best way to do it. So if you take the mass times the percentage, okay, you will get 342 grams of gold. Okay, so again, you're taking 68% of 500. Or you could say, okay, I know 68% out of 100. Okay, again, the percentage over 100 is how many grams of gold over 500. Remember, the 500 grams is your 100%. Okay, and so if the 68 out of 100, which is what percentage means, okay, what would be X out of that? And of course, if you cross multiply, you will get, again, 342 grams of gold. So either way that you do this, you're going to get the same answer. I think understanding your percentages here is a better way. Again, you just change your percent to decimal and you multiply by 500 and you get the end. But again, there are people who like this, this percentage. And if you ever remember, I don't know if you knew this, but the word percentage, the percent sign itself, is a little fun fact of the day, is actually a 100 that's scrambled. Somebody took the 1 and placed it in between the two there. So you didn't know that, did you? So that's your fun fact of the day. Okay, so that's percentage composition. This is how we use it, okay, to solve problems. Okay, and hey, big deal. Hey, 342 grams of gold, that's not bad. If you recover that, I wonder how much that costs. I'll let you figure that out. All right, have a great day. Talk to you soon.